This is the last module of the introduction, applications. You will see that adhesive bonding is applied basically everywhere. Let's go now to the last part of the introduction, where I will give you some applications. Let's start with the pioneer industry. I recall you, the aeronautical industry. And we have here a nice comparison where how it was years ago with a lot of rivets and how it is now. There are still rivets, but there is a lot more adhesive bonding. In fact, adhesive bonding in general is used with rivet. You have a hybrid joint in primary structures. Primary structure is a structure where when it fails, the airplane goes down. Secondary structure, it might fail, but the plane can still go on. And even though this industry is pioneer in the use of adhesives, they are still reluctant to use it alone in primary structures. So they would use it, okay, but with an additional joining method such as rivet. You have here examples in the fuselage where the adhesive is used for the reinforcement in many places, in the wings, in the main body. You have here the construction of a sandwich structure. We already discussed this in the previous module, but I just want to show you a demo of the impact that this structure can have in terms of strength and in terms of stiffness. The secret of this technology is this. It's the bending stiffness, which is to the power 3. So when you increase 3, it's to the power 3, the increase in strength and in stiffness. Let me show you. So I have 4 beams. The skin is a composite and the core is a foam, and here there is practically no foam, okay? And I can bend it very, very, very easily. So that's these cases in the slide. Then I'm increasing the foam and I bend it, and already I have more difficulty to bend. The bending stiffness increases, but the weight is constant because the foam has no weight, okay? Then the foam is increasing and nearly I can't bend anymore, just a tiny bit. And finally, with the big foam, okay, impossible to bend, okay? So that's the magic of the foam. You increase the thickness with the weight, it stays the same, and the stiffness of the beam is nearly infinite now. You go from 1, a relation of 1 to 37 when you increase 3 times the thickness. Can you see? Really, really impressive. Composite structures, honeycombs, they are used increasingly in airplanes. What's the reason? Because you can have a lighter structure, so you can fly more and save on weight. And there is here this graph over the years, the evolution of various types of materials. And the composite, clearly, as you can see, is taking off, all right? Why it's important to talk about the use of composite? Because composite and adhesives are married. Every time you put composite, you put adhesive. That's the most efficient way to join composite materials. Composite materials are very, very sensitive to holes. So they hate rivets, for example. So clearly, you have only one alternative, it's adhesive. Aerospace, there are many cases of the use of adhesive bonding in aerospace, again, because of the weight. You have here a very interesting application. It's a reflective shield for the satellite industry, made of a honeycomb, you can see. So, of course, the material is adhesively bonded, and then you have these reinforcements that are adhesively bonded. So, adhesive basically everywhere. Then you have these applications, very interesting. It's a vehicle or aerospace vehicle made of metal, the frame, but then it's covered with cork. Cork is an excellent material in terms of thermal insulator, and it's adhesive bonded to the metallic part. You have here more cryogenic tanks in the rocket industry. where these plates are adhesively bonded to insulate the cryogenic tank. Automotive industry, aeronautical industry were the pioneers, but the automotive industry is coming really strong at the moment. In fact, there is a revolution taking place at the moment. As you know, we are going from combustion engines to electric engines. And if you want to be efficient, you need the structure to be very light. So they are using light materials like aluminum or composite. And to bond these light materials, adhesive bonding, of course, is an obvious alternative, an obvious choice. But even in the case of steel, you use also a lot of adhesive, which is what is indicated here, a common steel door, where you have a joint being made between the inner door and the outer door with adhesive. And in addition to adhesive, you have a joint by plastic deformation, in this case hemming. At the end, you put a bit of a sealant to protect the adhesive against water and make it more durable. The hood also of the car, we use increasingly thin sheets, and they don't have enough stiffness, so they would have an exterior part and an internal part, and they are adhesively bonded with all these adhesive beads. And here also some points to reinforce the stiffness. You have here more examples of the use of adhesive and other methods of joining a bit everywhere, and you see there are really in a car all the possible joining methods. In the case of adhesive, many times they put adhesive plus something else, like in airplanes, and you have a hybrid joint. In this case also it's in terms of production. The rivet, for example, would hold the adhesive in place until it's completely cured. And then also in service, you would have a safer structure, because in case the adhesive fails, you still have the rivet that holds the structure together. Adhesive bonding is very commonly used in car structures. In general, the adhesive is used with another method of joining, like a weld or like a rivet. In this car structure, it's very clear to see hybrid joints where you have the adhesive and the rivet. Like for example here, you can see very easily the adhesive and the rivet. The rivet is there to maintain in contact the substrates until the adhesive is perfectly hardened, and also it's safer to have an additional joining method in case the adhesive fails. Another situation that you have in cars is that you need to bond different types of materials: composite, magnesium alloys, aluminum alloys, steel, and the adhesive can compensate very, very well differences of thermal expansion and give you a sound structure. Here a very funny example where you have a structure made only of composite, okay? It's only composite, and all the parts were joined together with an adhesive, a two-part polyurethane, not very, very stiff, so that there is no delamination of the composite. This was for the body shop, all these examples, but in the assembly line you also have a lot of components that are bonded, and the most important one is the glass, the front window, that is adhesively bonded on the frame, the metallic frame, using a one-part polyurethane. It's very flexible, and that is needed because you are bonding glass against metal, and you need an adhesive that can compensate the differences of expansion. Trains and buses also a lot used. In the case of the trains, the side panels are adhesively bonded, the windows are adhesively bonded. In the case of buses, all the windows are adhesively bonded with a one-part polyurethane. The naval industry, especially the boats, recreational boats that use a lot of composite, you have adhesive everywhere, and different types of adhesives for structural application, for insulation, for sealants. It's basically everywhere. You have a lot of sandwich structures also in planes, and you have here example of joints that you can follow to have a good strength. You see that when you load this joint like this, you will have a lot of peel, so you can use reinforcement to decrease the peel and increase the shear component. It's always the same philosophy. But it's not only in the transport industry, it's not only in mechanical devices. You also use adhesives in civil applications to bond the tiles, for example, very typical applications. You have tiles everywhere in Portugal. Glass is increasingly used in the construction of buildings, so all these huge glasses, they will be adhesively bonded. You have a beautiful building in Porto, the music house. You have a lot of cases where you have the use of adhesive. And plywood also, agglomerated wood is a material that is coming stronger and stronger. It's ecological, and all the agglomeration is done with adhesives. So basically adhesives are everywhere, and still there are applications here that I didn't put, like the electronic industry that uses also a lot of adhesives. So the moral of the story here is everywhere you look at, you would have adhesive. So important to be familiar with this technology.